Sometimes it isn't clear that you can do integration by parts until after you perform some substitution. For example, let's attack this integral, the integral of e to the square root of x dx. We'll start by making a substitution that looks totally unjustified, but in retrospect will turn out to be a brilliant move. Well, here's the substitution I'm proposing. Let's set u equal to the square root of x. How does that change the integral? So in this case, if u is the square root of x, then du is 1 over 2 square roots of x dx. In other words, right, I could solve this and find that dx is 2u du. Now, what does that end up doing to the integral? Well, this integral then becomes the integral of e to the u, and instead of dx, it's now 2u du. Duh! Now, it's a polynomial times an exponential function. We can use parts. But if I'm going to use parts, I probably wanted to call them u and v, right? But I'll just change the names. Instead of talking about u and dv, I'll talk about v and dw. So in this problem, I'll have v be 2u, and dw will be e to the u du. And now the derivative of v, right, gives me that dv is 2 du, and an antiderivative here, I can pick one. I'll have w be e to the u. So in that case, what does parts tell me? Well, parts then tells me that this integral is the same thing as 2u e to the u minus the integral of w dv, which is e to the u times 2 du. But now this is an integration problem that I can do. I know an antiderivative of e to the u. So this is 2u e to the u minus 2e to the u. I'm going to go back now and remember that I set u equal to the square root of x. So this gives me 2 square root x e to the square root x minus 2e to the square root x. If I notice there's a common factor of 2e to the square root x, I could collect those terms and write this as 2e to the square root x times the square root of x minus 1. And that's an antiderivative for e to the square root of x. And if I want to be a little bit more careful, maybe I'll include a plus c at the end. We did it! Contrast that with, say, this integration problem, the integral of e to the negative x squared dx. This is an integration problem that I can't solve using the functions that I have at hand. And yet this problem looks really similar to the original problem here, e to the square root of x, right? It's e to some power of x. So you'd think that if we can solve this one, we should also be able to solve this one. Seemingly similar problems, right, can have totally different outcomes.